Hi everyone, it's Dmitry and today we are solving Advent of Code 2023 in OCaml. Today is going to be day 2, part 1. So I made a recording of day 1, part 1 on Twitch and uploaded to YouTube. I didn't manage to record part 2, but you can find all the solutions on GitHub. And just to quickly recap what changed, now every day solution will be, and every part will be a separate directory in our OCaml project, and the layout of this directory is pretty simple: one executable file and one Dune file. And the Dune file is pretty simple. So to create a new solution, I simply copy my directory. Day 1 part, let's do part 1. To day 2 part 1, and I need to add a -r flag to copy directory. So now I have a new solution, and all I need to change is just this line in the executable, so I can actually run my program. Let's try to see if it actually works. I can run dune exec day 1 part, no sorry, day 2 part 1, and it still works and produces the output that we had. So let's start with the problem. I think you already should be familiar with this, and I assume you read it, but the idea is that we have several games, so each line is a game. So again, we're going to process input line by line, and each game has an ID, and it has some sets, a list of sets. Sets are separated by semicolon, and a single set has blue and red cube, so specifies how many it can skip, or green cubes. So you see the game might have only one, the set might have only one color, or 3 or 2, so any number of colors, but it should be no more than 3. And we need to find out such games where all sets are valid. And the sets are valid if the number of red cubes is less or equal than 12, and the number of green cubes is less or equal than 13, and 14 for blue ones. So again, pretty straightforward, but this time let's use some type-driven development and introduce some data types. So this was our solution previously. We still need to process input line by line. So this part is solved, but our solve part changes. So we are going to remove some functions we don't no longer need, like decode and to digit. No, we still might need to have digit. Anyway, let's well, we can have decode. Anyway, let's remove. Don't need it. So what we're going to do, we're going to split into lines. We're going to parse every line into a game, and then filter all games and all valid games, and finally add all game IDs. So now we will have 4 steps. We're going to just split into lines, parse, and find the result. So we already have a function to sum all the numbers and to parse. Let's do the parsing. And for parsing, it's important to understand that we are going to work with strings, and it will help us if we introduce some structured data. So let's think, what do we have? So we have a game. So a game has an ID, and it has a list of game sets. So this could be our data type. In OCaml, we use the type keyword. So type game is this stuff. We have ID, which is an integer, and you can imagine how much joy it brings me as an ex-Haskell developer to just type the name of the field as just ID, not some game ID. And we will have sets. And sets is a list of game set data type. So what is a game set? Let's introduce this data type as well. So in a game set, we have red, green, and blue cubes, but there might not be any, and we will consider them as 0. So this is just a simple data type with 3 fields: red, green, blue. And this is what are we going to model. And now with these data types, we are able to parse a single line into our model. So let's do this. Let's implement the parse function, which takes a line, which is a simple string, and it will return us a game. So we're going to parse game with list of sets from a single line. But so all inputs are valid in advent of quote. You don't need to worry about it. But let's just, for simplification, assume that our parser can fail and we may not return a game. So it will be an option, just to simplify things a little bit. So there are multiple ways to parse input in functional programming languages, one being regular expression, another being parser combinators. There are also parser generators. This input seems pretty easy, so let's not worry too much about it. So first of all, what we're going to do, we're going to split by colon to extract like the game ID part and all the sets, and then on the sets we are going to split by semicolon to extract all the sets, and then every sets we're going to split by colon and then we're going to parse each individually. So let's take one step at a time. First of all, match. We are going to use pattern matching again. So we have the string split on character, and split on character first takes character and the string. So we are going to split by colon our line, and we are going to match it. If we have like a list of two elements, a game and sets, then we're going to do some work. Otherwise we are going to return none. So we parse only valid inputs and we don't care about others. What Zara says, the match case could not be refuted. Okay, game sets. Maybe it's just, I see, it's just a weird parsing error. Okay, this is valid. So we're only interested in the list. When we split by colon, we have two elements, the game on the left and name of the sets. So what we're going to do, we're going to parse game and we're going to parse sets. So let's say our game ID, so our ID will be parse game ID. We'll have a separate function just for sure, and well, after completion can be cruel. And our sets will be parse sets in sets, and we are going to return a record with ID and sets, and we wrap it in a sum. So each of this function might fail, but again, we are going to ignore this stuff. So let's implement this couple helper functions. So parse game ID. Let's parse game ID. This function will take string and it will return us an integer, which is the game ID. And here, let's just copy the input just to put a comment. So this function are going to take this string and we're going to return us the number 11. So this is what we're going to extract. So we just need to split by space and basically extract the number and convert it to a number. So again, match, there will be lots of string splitting on character space, our line S with we don't need to validate input too much, so we don't care about first element, we care about number, and we're going to return string of this is from module int of, okay, maybe autocompletion doesn't work, so let's find the function how to actually convert string to integer. And let's go to int module, OCaml int module. So converting to string. So we have toString. I see. Okay. There is no standard function. I'm pretty sure, I swear, like I saw one. Converting binary decoding of integers. This is a binary decoding of integers. Anyway, OCaml string to integer. How do I parse an int from a string? Use int of string function. Okay, this is a module stdlib int of string. Okay, I just haven't found the proper function. Anyway, so int of string of number n. Otherwise, let's fail. I guess we can return -1 for now. Pretty poor error handling from this side, but let's ignore this for now. Okay, so we parsed game ID. Now let's parse sets. Let's parse sets. Again, we are going to take a string, and now we are going to return a list of game sets. So again, let's copy the example input to get the idea. So here we have this line. Let's actually put it in multiple lines. This line, and we are going to convert it to a list of 3 elements. First record will be R3 blue, blue 3, red 4, green 0, and so on. So we are going to split by semicolon, then split by colon, and so on. Again, let take string, set strings, string, split on character, semicolon. So we split elements of the list by semicolon. You notice how in the input elements of the list are separated by semicolon, just like in OCaml. Interesting. Maybe the author saved some Easter eggs. So we set, and we're just going to do list map parse single set. So we extract, and we're just going to parse single set from set strings. Actually, we can just use pipelining of functions. This should be a character, obviously. And yeah, lots of string splitting. Let's parse set. Again, we take a string, lowercase, and we return a single game set this time. Actually, need to specify this. This is why it's complained. Set not valid parse set. Anyway, again, let's add a comment. We are going to parse string like this. To a single record. We already specified it, so no need to worry about it. So one interesting thing is that here, when we split by colon, we actually left a space here in front of a number, so we need to be mindful about it. Maybe it doesn't matter, but if it matters, we will have to figure something out if it doesn't work. Anyway, what? So how does it call it? What are the parts of a game set? Bag. From the bag, for example, there are games in the game, 3 sets of cubes. It was just call them cubes. String split on character colon our line in, and now we need to parse this input, but we don't actually know the order. It can be green first, red first, blue first, or whatever. So what we can do, we can start with kind of like an empty game set where everything is 0, and we can process one by one. If it's green, we set green field to green. If it's red, we update the red field. Otherwise, we update the blue, and so on. So this is what we're going to do. And for this, we can use again our function from day one, which is called fold. OCaml. Let's have a look at it. I thought it would be okay. Maybe it's in iterators. Okay, so we start with some accumulator, which can be like a 0 game set, and then we consider one element one line by line, and we update it until we finish in the end. So this is what we are going to do. We are going to use list fold left with our function. Let's call it parse cube, and we are going to start with 0 arc, and we are going to parse cubes. And again, we can just do pipelining here to avoid creating redundant names. So we need to have 0 like init game set. So it can be a global value, it doesn't change because values in OCaml are immutable. Init game set, this will be a value of type game set, and it will be a record. You can just copy this. We start from 0. This will be our init game set, global immutable value, and then we are going to we are going to parse cube by we're going to parse single cube. So let's do this. Let's implement a helper function. It's relevant only for this module. Parse cube. This is function, since it's an argument to fold left. It's going to tell a game set, a string, and return a game set. So let's just do this arc, which is our game set, then s, which is a string. You see here we use name shadowing, so this s here is not the same, so this is fine. We are going to return a game set. So here again we split our s string here by spaces, and we get the number from the left, but we pattern match on the value on the right. And depending on the color of the value of the string, we are going to update our accumulator accordingly. Match string split on chart. That's lots of string splitting. Again, so if it's some number n and the string red, sorry, it should be semicolon. Then we are going to update accumulator. So we are not going to mutate it. We are going to create a new copy, so it's not a mutable value, but this is fine. We don't change our initial 0 accumulator, we just create a new one. And we just say that red equals to int of string n. And we're just going to repeat the same. If it's green, we're going to update green. If it's blue, we are going to update blue. Otherwise, we don't update a co-accumulator. We consider that this is a like an invalid input, but this should not happen. So let's align it properly. So we just can see this symmetric structure. So we just get a number, we pattern match on the string, and we get. So yeah, this is almost our solution. Now we need to put all the pieces together. So in our solve function, we are going to use list map, but instead we are going to use list filter map function, which takes an option, and we are going to use parse, our parse function. So this returns us a list of game sets, and you can see that function sum expects a list of int, and we gave in a list of games. So what we're going to do, we can just do list map fun game. Actually, first we need to filter. List filter is valid game. So this function will now check cube. So we parsed. This is our first part of the problem, and now we'll need to check if the game is actually valid. So let's check if is valid game. We take a game of type game and we return bool. And here what we can do is that we don't care about ID. We can just bring the sets into scope. So this is sets is a value of type. This is we pattern match on a record. We only care about sets. And now we need to check that every set is valid. I'm pretty sure there is such function in the lists scanning for all. So for all checks if all elements of the list satisfy the predicate. So this is what we're going to do. It returns for an empty list, and true if the list is empty. Okay, so this is what we're going to do. We're going to do list for all is valid set for sets. You see how I introduce several helper functions just to like kind of decompose the problem into smaller parts. And yeah, let's implement is valid set. It's going basically almost the same. Set so now we just need to check that the number of cubes is the same as specified according to the task. So set red is less than equal than how much? Let's double check. 12 for red, 13 for green, and 14 for blue. And set green is less than equal 13, and set blue is less than equal 14. So yeah, green 13, double check. Green 13, blue 14. Okay, yeah. So now we filter our games by having a valid games, and now we need to extract game IDs. So now we're going to use map again. Fun game. We're just going to get game ID, and we're going to get sums. So this might not be the most performant way of implementing the problem. So we traverse the string multiple times. It should be okay for this input, and because this list are like strict, we will traverse the same list multiple times. There are multiple ways to do this, but yeah, let's just try to test it. If this should be okay for Advent of Code. I think Advent of Code is not really performance sensitive. So this is our example. Let's hope it works. This example from the previous. Nice part about Dune is that it actually recompiles the code if it's changed, so I don't need to run Dune build again. I can just execute my stuff. Okay, I actually haven't used some of the functions like isDigit and toDigit. These are errors in OCaml by default. So let's just remove them. Looks like we actually didn't need them in the end. Didn't save the file. Okay, number is 15. Is it the correct result? To anyway would have been possible if the back had been loaded with that configuration. However, gain 3 would have been impossible. Okay, it looks like we actually found some of all numbers and not let's see. Well, guess what, we can try to debug. We know that the game 3 is invalid, so let's try to see if we parsed it incorrectly. This is what we're going to debug, and we are going to use utop for that. We are going to use day 02 part 1 main, and we're going to parse. Oops. So we have a game. It didn't update our accumulator. Okay, so what's wrong? I see. This was a problem that I mentioned in the beginning, that here we have like a space, and yeah, when we split by this symbol and by this, we get space like around. So actually before we split by colon, when we do this, we actually need to do string trim s. So we remove all the leading and trailing spaces just to make sure that it works. Let's try to test. Okay, still doesn't work. We parse the game. See, okay, when I actually split by colon, I need to do this again. Man. What's the best way to do this? Okay, let input be string trim s. Now we split input. Maybe not the cleanest. Okay, now we actually parse correctly. Yeah, parsing can be tricky, that's why using something like parser combinators might be beneficial. So let's try to do again. Now we have 8. Okay, now I'm more confident in the result. So let's get our puzzle input. became 100, pretty sure. So, and yeah, let's run on the input. The result is 265. So let's try to insert to see if we made it correctly. And that's the right answer. Okay, so yeah, we managed to solve day 2 part 1. Hope to record more in the future, and thank you for watching me.